about Iris. Iris is a platform which gives you an opportunity to get you recognition on the world stage. We inspire you to research and innovation in the field of science. Iris guides and mentors you to improve your research-based project. Once you get selected, you get mentored with the expert of scientific review committee. Our objective is to stimulate young minds to take an active interest in science and technology, to encourage you to use research as a tool for creating new knowledge and building a scientific temper. The annual timeline of IRIS, this is the time when we reach out to schools, but because of the current crisis, we are doing the webinar sessions, and I'm sure we all like it. And very soon we'll be opening the entries, project entries. The submission will happen online. And once you submit your project, the shortlisting happens. And after that, we announce the national fair dates. IRIS reached out to student teachers and schools across the country. And till now, we have touched over 4 million students. And in future, we'll keep counting. Participation eligibility in IRIS is for students from class 5th to 12th. Firstly, the students are of Indian origin. That's a very important point. Students of Indian origin, and they should be from the schools based in India. There are two categories. One is junior, for which is 5th to 8th standard. The junior category student qualifies for special awards and Broadcom Masters Award. Broadcom Masters Awards participants, they go to ISEF with Team India, but they do not compete in ISEF per se. The senior category students are from class 9 to 12th, and they compete for participation at ISEF. A very important point here is students who have completed their class 12th board exams this year, they will not be eligible to participate. You can support IRIS by volunteering. We do multiple outreach programs. We do national fair where you can, if you are a pass out student from class 12 or an undergrad student, you can volunteer in the fair. If you are a teacher, you can associate with us by mentoring students. You can mentor various students. We receive a lot of requests from students to provide mentors. So you can share your profile with us and we can align you with students who need your mentorship. And if you are part of an organization and you would like to collaborate with us, you can do that. Today's expert is Mr. Prasanna Banavara. Prasanna is a platform program manager at a multinational technology firm based in Bangalore. He has experience of over 14 years. He's a program manager, XFT lead for audio, in-device coexistence, thermal and power backoff in LTE SIM modem and LTE integrated SoC. He's a software architect and project manager in multimedia messaging, mobile phone platform, middleware, IP camera solution integrated with mobile phones, video conference systems, remote diagnostics for home appliances. He has 5 patents filed under his name. Welcome, Prasanna sir.
Hey, thank you very much, Shrey.
I would like to hand over the session to sir. Sir, you please carry on.
Prasanna, before that, I'd really like to welcome you. Thank you so much for taking time out to join us today. In fact, we've had a lot of queries and a lot of students have been waiting eagerly for this webinar. So welcome, and I'm sure you'll have a lot of questions at the end of your presentation. I wish that the students who are attending this take notes and keep their questions ready. So without further ado, thank you so much, Prasanna. You may please begin your presentation. Thank you.
Sure. Hey, thanks, Shrey and Sharon, for um, this opportunity to be with the young minds. I always feel like it is always encouraging. Um, Let me share, and mind you all, this is based on some of the case studies or some of the work which I've done. So I believe in giving something, whatever that is actually happening, rather than actually sharing some of the only contents which probably you can be probably seeing in the textbooks or in any of the information in the internet. So I've consolidated all these things and then I'll be sharing. So let me know when you can see my screen. Screen share. Okay, share. I started sharing my screen. Let me know.
Yes, it is up, sir.
Fantastic. Okay, so I'm calling this as an intelligent machine. What's there? What is there behind? Which means saying that okay, we have some beast which is there, and we are calling that as an intelligent machine. And what actually goes behind is something that I'll be sharing. And the entire thing, because I work in Intel, I'll be sharing this. Though I'm not trying to be more like trying to see all the because from the Intel perspective, but this is the information I have, and I'll be sharing what we have done and how the things actually happen. Okay, so our plan for today, though I've been given a complete slot of breakup of activities, how these things will be looking like. Is there any way where I can hide this? This keeps popping. Okay, it might not be visible to you all. Okay, no problem. So, Shrey, I hope I can. You guys can still see the screen, right?
Certainly, sir.
Perfect. Okay. So introduction. So I'll be giving a quick overview of what are the different things that actually happens here, and I'll also touch upon the AI, ML, DL, and all. Basically, what goes as a part of the image processing, how we do this, and some of the sensing and challenges. Same, basically, why when we do the sensing, what are the challenges that we have, and also talk about inferencing. How do we infer what the situation is on exactly on the road, and all these things again based on my experience on a machine called vehicle, right? So it's something like that. And the planning and actioning, which is about like going towards autonomous vehicles, and then finally we'll summarize by sharing some of the quick takeaways. Okay. So introduction. So any intelligent system will actually consist of some of the information saying that it has to see, like we always mimic our human beings. So we have five sense organs, which becomes an input, and then finally it gets into our system through the neural network that what we have, and then our brain actually computes, infers, and then finally it actually acts as to take any action. So this is a sensor, so where there are different kind of sensors where the data goes in, and then there is a perception that has been built. So this is what I'm calling it as a sensing input. And then the perception saying that basically inferencing saying that, okay, what did I see? Did I see a TV? Did I see a vehicle, an apple, or a child, or a human? What did I see? In the context, how is my road condition is what I'll be looking at. And I need to also know about this current road condition. A person is standing, is he on a pavement or is he on a road? So a knowledge about my environment and then localizing and then making it context sensitive. Once I know that, I'll have to respond. What are the different options that are available? So maturity of a person is based on how it chooses to respond. So the maturity of a machine is also based on how it actually responds, based on its behavior, and then motion capability, its agility, and basically what is the principle of that entire vehicle, what are the policies, how it has to behave, and it has to slow down, or is it supposed to hit the machine and destroy in the context of say like a war equipment or anything, right? So what is a machine that is behind, and then finally it makes a decision here, and then it takes the control by knowing what all my hardware mechanics and what all the different software aspects that actually happens behind. So that's where we're calling it as a controlling and action. And finally, it actually initiates the actuators to take some of the action via hardware where the physical changes happen. And based on the physical changes, so there is a complete sensing of all this information. It goes back to the feedback. Again, I understand whether did I overturn or underturn, Do I need to really initiate to take more turn or brake or whatever what the situation is? Based on the road condition, I'll have to keep. So there's a feedback mechanism which goes through the various sensors, and then this becomes a complete one. So aren't we doing the same thing whenever we have to have some of the motorized skills of doing any painting and all? So this is what the different things that actually happen. Now we'll try to dissect into each of these sensing, inferencing, planning, and control, how this all actually happen. This is more probably you can call it as a generic view, but if I go deep into something like what we had done and which is available, we use different systems for each of these things. We use a camera vision for to sense, and then we do the planning. So there's a huge bunch of policies, the inferencing and conclusion that actually happens. And then we use, say, any other microcontroller or maybe Atom, what we have from Intel to actually do the action. So there are different kind of input that are also coming in from the radar, LiDAR, predominantly from the camera. So this actually adds as a augmented data for redundancy to infer whatever I inferred is right or not. And that's how I'll be moving on. And there'll be a lot of other information that I'll be pulling in. We call it as a road experience management. So this is called as a REM, how we actually make use of the beyond intelligent, some of the basic aspects of getting the information from the current sensor. We are also augmenting with the sensors, the wisdom we call it as, right? So error is human, we keep doing the mistake, but the wisdom is when we learn from others. So can we learn from other machines and then take that as an input for a better driving conditions on the road? This is what the overall system looks like, where I'm actually looking at, we'll be talking about, or I'll be sharing some information. So a quick check, Shrey or Sharon, I think we have 20 minutes, right? So to share, or maybe max half an hour, and then we'll open for some of the queries. Is that the plan still?
Yes, yes, that
Okay,
is.
perfect. So because I'll try to articulate these things accordingly. So how does it all happen? Like if you can mimic our own intelligence, being a human as an intelligent being, we have five senses. So fortunately or unfortunately, we keep only seeing the same forward, and we have two eyes. So with that, we are also able to sense the depth. We have two ears. So because of that, we'll be able to sense the direction where the sound is coming. And we are able to even see the touch sense. We'll be able to know what is the wind pressure or whatever. And sound, eyes, and then of course we don't do the taste and all while we are navigating, but it is also some of the sensors that what we'll be using. So similarly, how does a machine, what are the things that we'll be having? We will be having a different kind of a sensing equipments that can be from, say, the long range radars to see whatever the far distances that are the vehicles are, or LiDAR, which is similar to the um, radar. In the context of radar, it is more about the radio frequency based on the reflection, but in the context of LiDAR, it is about the light detection and ranging. So where we'll be having a multi-channel LiDAR signal, which will be going light. And then based on the reflection, we're going to prepare a cloud, point cloud imaging, which helps in inferencing. And then of course the camera to see what is coming in the forward. So to understand the context, we'll be probably even looking at left and right to see whether am I safe to take a left turn or not, or whichever direction, and then also what can be the consequences if I'm actually applying a brake, and how do I handle the blind spot, which is generally the spot which is not seen from our eyes. Camera can actually augment it to help in navigation. And the short and medium ranges about the radar, which we generally see for the parking assistance to see if there are any objects at the bottom, and then how I can navigate. And of course, on the ultrasound to see um, what proximity I am in with respect to the obstacles. Now, with all these things made available, can I really look at saying that how I can make use of all this information? So I've just tried to copy some of, just for the information, the cameras are good for object recognition, pedestrians, traffic signal. Something that we all need to understand about even the traffic signal, the cameras are required because it's almost going to mimic the human eye, but not good for accurate distance. We'll try to see what all the challenges that we have. Though there are a lot of the time of flight kind of a mechanism used for identifying um, the distances, and also two cameras are also there to do the analysis of the distance, which are available in many of the mobile phones nowadays to come out with the 3D pictures and all. So, but it is definitely a challenge to identify the distance. But on the whereas on the LiDAR, it is good for the better estimation because we get a time of flight. I see some of you are actually trying to experiment on the screen by scratching. I request you to refrain from that. Yeah. So good for the better estimate and then the distance. However, it is not good for the object recognition. It's even applicable even in the context of radar, where it is able to detect there is an object, but is that object a stone or a human or a dog or a tree? No, it cannot, but it can compensate. Now, can I do a comparison of all? So a camera, you can identify saying that the object detection, okay, fairly good. Object classification, it is very good. Distance, okay. Object precision, lane tracking. So all the things where you have a very good light condition in the driving, camera can actually help. If I don't have a good light condition, and even if I'm planning for an infrared camera or anything, I may not be in a better position to achieve all the things that I can do where a normal camera can do with a very good light condition. However, on the radar as such, it has a multiple on the object detection, though it says that saying that, okay, I have an obstacle, but can I identify what the object is? Never. So that's why it is red. Also, the estimation again based on the radar, the distance and all. That's why it is able to identify in what you can call it in the missile and the defense segment and all. Lane tracking, definitely not. It cannot see, so it cannot. So range estimation and all the other things. It is also good in the bad weather because the radio signal definitely travels through. Whereas in the context of bad weather with the camera, it is not. So I'll not go deep into it, but you can see there are combinations as alone. If someone says, I have designed an autonomous vehicle only with radar, you know the disadvantages. If someone says I have a completely camera-based solution, you know the disadvantages. Then the best combination will be like, okay, you need to have a multi-sensors combination, which is going to augment each other and contribute for identifying the various aspects which are required um, for my autonomous intelligent mission. So what are we looking at? I have a sensor. Now, what are the different sensors, what type of data that they give, and how do it helps in inferring. Now I know, can I know what are the different challenges that goes in? Because I see an image and I need to know whether it is a dog or a tree or anything, but what is it actually? And we'll be looking at the challenges. Okay, so far, that's what we looked at the sensors. Now let me quickly introduce onto the AI ML because just to put into the context, artificial intelligence is about that we can sense, reason, and act and adapt. That's what we actually gave it in the initial model. And the machine learning is about enabling the machine to get exposed to more data over time. So it has to be like a child, where the child learns saying that this is a fire. If I touch, I'm getting a heat. Or if the child identifies that this is the marble, and then this is, if I'm asking the child to sort the different color marbles, it identifies through some of the guidance, and then it identifies by itself. These are the machine learning. And the deep learning is about the multi-layer neural network to learn the vast amount of data, because I'll be sharing saying that the amount of the data that comes in, and then finally you will have to make the decision while driving the car, maybe around 80 kilometers or maybe 120 kilometers, where the top speeds are there in some of the countries. So how we are going to take care. So uh, I would like to tell a story. I think someone is still exploring how to use the Zoom and then the brush and all. Please refrain from doing that. Actually, it is distracting. Okay, so there was a person in Bangalore around 2 decades back, and he was very well known in the news, saying that the person has invented a, a pram or a kind of a cradle, which has so many arms, where when the child cries, it can actually extend, and then it can even start feeding the child with um, with the milk, or if the child is there is a the child actually makes its the bed wet, then it actually can raise an alarm to the mother saying that the child has made the bed wet, so it requires an nappy change, and so on. And then the media actually projected saying that a smart engineer, like it always tries to do, they wanted to say that, okay, the child has invented a robot which can actually help the child. And they, in fact, there was a lot of socializing activity, not through the social media, which did not exist, but they started going to Center for Artificial Intelligence and Robotics establishment, which is CARE in India. And I happened to interact with some of the people from CARE post that, because the person has joined our company, and he said that child was misguided, and he was told saying that, okay, it is an intelligent machine, but I challenged not to discourage him, saying that this is not an intelligent machine. So what is the difference between an intelligent machine and then the one what was the child has responded? So what was that being done earlier was, is there is a system where there is an stimulus and there is an action. What is the stimulus? There is a sensor. The sensor identifies that there is a sound of a child crying. So it sees a glitch in the microphone, and then you can have any kind of filters. And then when it crosses a threshold multiple times, you can identify that the child is crying. And then you can move the arm of the robot to actually feed the milk, which is already fed. Now, what if a person standing outside make a sound of a child, right? So I have a induction stove, and it has a concept of saying that multiple visuals, you don't need to keep a count. You turn it on and then walk out and set how many times the pressure cooker will have to whistle, it will switch off. I just tried once saying that making the hissing noise in the background and incremented the count. So the intelligent system is definitely not intelligent enough to adapt to the environment, and it is also not in a position to learn. So the difference between an intelligent system is that it should be able to learn based on the different points of the data that one actually looks in. It is not actually a stimulus and response alone, though it is one of the input required for any of the machine, because sensor input is required, but just by responding to a situation is not intelligent enough. Had it been really an intelligent system, probably if a person is making sound outside and the child is soundly sleeping, there has to be an image processing saying that, okay, child face actually says that it's still sleeping, eyes are closed, and it's still not woken up, and there should not be any false alarm. So this is what an intelligent system is all about. And also, like, you can further improve to say, like, okay, is it supposed to monitor that child or any child? So if that child is sleeping, I don't need to do anything. So these are some of the things that we'll have to really look. So this tells about like what the machine learning is all about. It's all about like a kind, when they say like it has to learn the data of, oops, what happened? Someone blanked. Can someone help me? What happened here?
Hello.
Yeah,
Yeah, I think you're back.
it seems like someone is
Someone is
experimenting.
trying
Yeah.
to, yes, I think participants, this is something that is really uncalled for and very impolite. When the speaker is presenting slides or expressing something, please refrain from annotating on the slides, or else if you have I mean, if you cannot refrain from doing that, then we would politely ask you to leave the meeting. Please do not annotate on the slides.
Sorry to interrupt, sir. There is an option. If you on the top, you can see an option in privacy. You can see annotate. You can shut the annotate from there, so nobody can annotate on the screen further.
um am I visible with all those information? Can you see that information? Try
No.
more.
I so on the top, if you see the
Disable participant annotate. Yeah.
right, please do that.
Okay. Thank you, Shrey. I use other channels of communication. The Zoom I'm not used for presenting so far. So thanks for helping me out. Okay, so this is where we are. Now, let us take an example of what happens with respect to the intelligent machine, say in this context, a vehicle. There are a lot of, actually I've come out with a mind map to say like about the machine learning. There are different things. We'll not go into it for the sake of time. So what actually happens is like we have the real-time data here um, from the external world. It goes through the CNN or the neural network, deep neural network, with a math model, and then it should actually be able to identify that there is a person. Now, there we generally have is a training data set which actually enables, or the child in this context, the vehicle has to get exposed to knowing the entire environment, the dynamics, the different geos, different driving conditions of various places, and it has to really identify what each of these things mean. So, and it goes through that, and then there is a scoring which actually says like how it comes into a participant. I mean, sorry, into the real world based on the trained data set. When it goes to the real world, am I identifying it is a person at what confidence? So 97%. So this is how it'll start building the data, and then it'll be going in. Now we'll try to see how difficult or challenging it is to go further into these things. So if I look at what generally we do is we have to have a good number of training data set. The child has to start learning about, okay, this is a mango, this is a orange. Similarly, the vehicle has to learn, this is a road, this is a pavement, these are the people, the people are crossing. How can I do that? So we'll have to train the data set. So there's a pre-processing, learning and error analysis will be done, and that goes in as a machine learning model. And then you also try to give a training data set where you try to see, if I put the whole thing into the real world, am I really expecting my machine to identify what I really asked or trained it to be learning? So it is as good as I train my child to identify to know what is a dog and a cat. So the child has learned what is a dog and a cat, and now I take the child as never exposed to a fox or a wolf, and now the moment the child sees that it's a fox, I mean it's a fox, but it identifies that it is a dog. Now you will correct it by saying, no, 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 this is also looks like that, but see, can you see the differentiate between a dog and a wolf or a fox? And then it will try. So that's a continuous learning. But at the first time, the data set, the wolf was never part of the training data set. Then the wolf was given. So what will be the prediction of my model? It'll probably talk about saying it is a dog. So it has to be fed back, and now it has to identify. Next time it goes to a jungle and identify that it sees a wolf, then it probably can differentiate between a wolf and a dog. So there are a lot of simpler examples that we can. So it's all about how you train the child or the machine in this context. Now, is it as simple as saying that, okay, I have the data set, I give it to a machine and it learns? Is it as simple? No. So what goes behind, as I mentioned already, what we did was we created the first unstructured data driving condition in India and for the entire world, because we believe um, in India, if we start learning to drive and also handle the unstructured driving conditions, the system will be much more intelligent than any other places, because you have a better driving conditions, say in Europe or in US and other countries. So we created this. Now this entire data set is available for public as an open data challenge. And this was partnered with IIITH, and then we have done, and this has been freely available. I can share the link through our organizers here if anybody is interested. So anybody can actually download this data set and try to train your model, and then say your model is better or not, and so on. And whenever we come out with some of the challenges through IIITH, you can always participate and then see like how your system is much better. Okay. So with that, I'll try to say like basically what are the pillars of autonomous vehicle? You need to have the sensors and the data, the machine learning model, the data science, and then computer vision. So intersection of all this is something. What I did was we created, there were a lot of other data sets like cityscapes, kitty and all. But what we did was we created a data set for Indian driving condition, because we see this wild east kind of a thing, saying that this is a kind of a thing where you can't identify. You can see the people crossing the road, you can see the work that is going on. So all these kind of dynamics are all seen in the on the road, right? So what we did first, as a part of the sensor, for my system to for the part of the sensor data, you give the data, you want your system to learn. What it did, we actually had a vehicle which had a multi-sensor camera data along with the lidar. You can see the lidar here. We have four cameras with the surround view, and also we had the GPS to locate where the vehicles were going, and we were capturing the multimodal data where you can see the left, right, forward, back, and so on. And with the lidar, you even we are able to see the information similar to the cloud map, which I'll be sharing it later. So this is how the vehicle looked for capturing the data, and we have thousands of kilometers data. Now, what did we do? We captured the live stream. Next, what we need to do, this is a camera image that comes in. Each of these camera image will have to be fine annotated. This is done manually to identify this. You can see that the pink color, the dark pink color is actually the road, and then the dark blue is actually the cars, and light blue is a two-wheeler. People are in red, and the trees are all in green, and you have the payments all being differently colored. So this is called as a fine annotation, where we hire people and then they annotate, and this exactly goes into the machine learning as an input for learning. And we'll also do a course annotation where we draw a bounding box, and then which actually helps in identifying what it is, motorcycle and all. So this actually goes as an input for machine learning. So what my machine will be able to learn is, every time it goes through this, among these, what are all the different things that I'll be able to identify. Like I said, I have exposed a child to identify initially the dog and the cat. Now I'm exposing the child to learn about the wolf. So similarly, I explain my child, that is a machine, to know that this is road, so on and so forth, payment, drivable area, non-drivable. So many things are all being categorized. So this is going to be the labeling or the categorization of the data. So the categorizes, it actually says the drivable area, non-drivable area, living things, vehicles, roadside objects, for objects, sky, not for training. So there are some things which is not required for training. Is also that is something that is then being added. Who does all this? You might be knowing about the supervised learning. So we actually start doing all this kind of a categorization, like what we did with the fine and then the course annotation. Now, once that is being able to do with a lot of multi-layer, my system will be able to predict going forward, saying that what it is all about. It can be, we can use a clustering mechanism to see if I made any other categorization that need to be done. So that is what we have evolved than the conventional data sets that are available. So this is an example of which says like this is a raw image, and then finally what is a ground truth, that this is what is it, and then finally what we are going to identify from the different systems, and how do I uh, identify. So it can so happen that if the system has been learned, if a system A has learned the driving conditions which are in say US or in Europe, now you expose the Indian driving condition, okay? So that system will be terribly confused, saying that it may not even know where is a drivable area, what is not a drivable area, what is a vehicle and what is not a vehicle, because you saw some of the protruding things that were coming out of the vehicle and all. Uh, Whether you can be happy or unhappy, this is what the reality that is unfortunately happening in India. So with that, that system will not be able to identify what it is. So it becomes very important for my system to get more and more intelligent. What is the criteria? It has to get exposed to the diversified knowledge or the data set. which happens with the Indian data conditions. Okay, I shared all this. So I told like this is how the LiDAR data will look like. Of course, this is a Velodyne LiDAR, which is the one which is there are a lot of other mostly used as a Velodyne, but this is actually a better sensor. Just to let you know, the cost may be in few lakhs or maybe tens of lakhs. That's how the cost of LiDARs are. Of course, one, the economy of scale will it can be coming out. So what we are trying to identify over here is it's not a basically image, it's a point cloud. The resolution, it has a 32 channels, so there'll be a light that will be rotating, a number of light signal that will be going in. So based on the reflection time of light, it's going to identify where the point is. And then if I integrate all this, I'll be able to identify how the object looks like, and then probably superimposing on a camera image, you can be able to compare what the reality the road is about. Okay, this is some of the roadmap that I'm telling from the live case study, saying that we started. I'm here. My team scientists were all here from different collaboration, and it was in Triple ITH. So there are a lot of people who have won these data challenges. There was also one thing which said like auto rickshaw challenge that you can see here. This was there earlier. So this data has gone IDD. If you can search on the net, so you can use it for any of the data set and then go for the challenges. So it's really exciting to see like how we have created the data and how it is getting used and how we are building the traction. Again, I'm saying that it's an open forum. It is for the community. It is for all the people globally, for the universities to do the research. And then we are taking it to along with Triple ITH to share the data. Okay, what did we do now? We actually took the data and we identified what are the challenges that goes behind for an intelligent machine in identifying. Now the next aspect is about inferring. What do I by inferring means? I need to conclude what did I find. So my system will definitely look into different inferences, and then it can build into a different kind of use cases. So I'm going to introduce about the first level of inferencing, and then just by knowing how I can make use of all this. So let me introduce to ADAS, Advanced Driver Assisted System. You might be knowing that it is also available in India. There are a lot of retrofits and many vehicles are also coming in, and it is also been mandated so that it will be coming out by next few years as a default feature in many of the vehicles. So some of the data ADAS related are anti-lock braking system, adaptive cruise control. This is going to be managed through our camera systems, blind spot detection, again through the camera system, driver drowsiness detection, the inward facing camera to say whether the driver is drowsy or not. This might be part of the systems that many people provide. The ESC, the electronic stability control, emergency brakings. You might have all seen the Volvo ad, which where the vehicle actually stops based on the obstacles that is coming in when the driver is taking off his hands from the steering, as well as no legs on the brake as well. There are different things. So the lane departure warning and all. Let me show you like what are the different use cases that can be really looked. I hope you'll be able to see that in the video. Before that, the different level of um, the autonomous driving. So level 0 is where you infer or there is nothing like fully driver is controlling, but you may get some information. So that is what the ADAS system is all about. The level 2 is about you actually give that input to of the ADAS for automatic emergency braking or lane keep assist, where it ensures that you are keeping the lane on the lane. This belongs to level 1 and 2. There are under certain circumstances, maybe it is an in-campus driving or a very controlled, maybe you're going around in Lal Bagh, so it is a known environment, and the vehicle is moving slowly, so you can probably automate it. Or maybe in a flight for a transit, you can probably automate it because the number of obstacles can be very minimal or the challenges will be low. So these are some of the things that one can think of. And then fully autonomous is like probably you will not have a system even as there is no steering at all. So how it is, that is the level 4 and 5. There is an interesting that is also actually coming up with it between level 2 and 3, which is a 2.5, which actually talks about the road experience management and road books, which are also some of the things which I'll be talking about. Why? Because one of the input, like I shared you earlier, it's about the GPS coordinates telling the location, and also I need to know about the environment, where I am, whether I'm in a congested area, if it is something so, um, to make use of all the information, and how do I manage the dynamics of the different situation, because today a road may be one way today, but tomorrow it may not be, or the vice versa. So how do I dynamically change, because autonomous vehicle, or it has to help the driver by doing an ADAS kind of a system. So that being the thing, so I'll quickly give a here saying that what all ADAS can do. It's a quick introduction about, say, it stops with the notification in the video that has been shared. I hope you can hear the audio, otherwise I'm going to supplement it with my comment. Okay, were you able to hear the audio, Shrey or Sharon?
No, sir.
So when I play the video, you're not able to hear the audio.
No. So you have to optimize your video separately in case you would like to. Like,
In
Are you able
critical
to hear now?
situations,
yes, sir, audible.
issues both a visual and auditory warning of an
So what you
impending
can see here
collision with the
is there was
vehicle
a warning
ahead.
that was coming because he got distracted, and it gave an audible alert
The
saying
system
that,
can
okay,
provide
you are
a
supposed to
warning of up to
apply the
2.7
brake.
seconds before
So this is
impact,
about the
both during
notification
city
that it
and
gives. The
highway
action is
driving.
completely taken by the driver. On the similar lines, it has the
In the
intelligence to
event of a
identify that
possible
there is a person
collision,
coming
the
in,
system issues an alert, providing you
and it
with
gives
up to
a
2 seconds to
humanoid
brake
kind
and
of an
prevent
icon
an
saying that
accident.
the person is there, and with the different decibel audio it is able to give. And again, he has
The
to apply the
mobilized
brakes,
system
right?
recognizes when the
So the
vehicle begins to
camera
drift from its
has an
lane
information.
without the
When the
use of
camera
a
is
turn
able to
signal
identify the
and issues an immediate
lane,
visual and auditory
and it
warning,
gave
prompting the
the lane
driver to
departure because
return
he did not
focus
use
to
a
the
signal,
wheel.
and then it gave an audio.
The mobilized system monitors the distance between your vehicle
It's
and
a
the
safe
one ahead of you
distance
at all
because
times and in
anytime
all
he
weather
approaches the
conditions.
braking, it has to have
The
the
mobilized system
sufficient time
provides a
installed.
precise,
So this is how
real-time
the camera will
indication
be
of the
looking it, and
distance
then
in
it will be showing
seconds.
the visual.
When the relative distance becomes unsafe,
So these are the different feedback that it provides, the forward collision. Now, with that, what are the things that we can do? We can take all this information and put it into the cloud, and you can actually generate a report to identify what are all the different places where you can have a different kind of an accident zones if there are a lot of warnings coming around. So this we call it as a gray spot. And you can also do a driver profiling, saying that if a driver is driving very rashly, whether he's a good driver or a bad driver, and is he supposed to be, say, we have even an indication saying speed limit. So if the speed limit says like, okay, it has to be around 80, and if the driver is crossing it, yeah, the warning when it comes, and if it is all aggregated, you will come to know that how often he violates. Is he maintaining the safe distance between the vehicle? Yes, no. So these are the things that we can. So some of the studies have told, like, if you give a warning 2 seconds before, you can give the information to the user, he can apply the brake, and then you can stop around 100% of the accident. So that's why this is the first level of um, the inferencing that can be done. So what is actually happening here? The data that has been fed in, it has been analyzed, and it identifies saying that you're going at a particular speed, and knowing what is the speed of the vehicle by reading the CAN data of the vehicle, and it identifies a person or the vehicle in the front, and it is able to make all the inferences, and then it is actually talking to the user with a notification. So that's what it actually happens. The second one, let me share that video. Okay, let me know again if you are able to hear the audio. Are you able to hear the audio?
Autonomous vehicles will need incredibly
Audible, sir.
precise maps that enable the vehicle to localize itself to a much higher accuracy than can be achieved with GPS. These maps are a requirement to meet functional safety standards for redundancy and must be up.
Now, what if my GPS is, I mean, if I'm driving in a tunnel, okay, can you think of a situation where the GPS signals are not there? And if that is not the case, how will my system know where it is and then how the driving conditions are? Of course, it can look at the system, which is, from the camera in the front, and it can identify. But the point I'm trying to introduce you is something like what all the further extended things that can be done here.
Dated with an ultra-high refresh rate to reflect changes in the road environment. Current mapping approaches with data collected by dedicated LiDAR-equipped survey vehicles are challenging to scale.
What actually happens right now for building any of the map, the vehicles will be on the road. It has a LiDAR. It keeps moving, so you can be seeing about a lot of Google vehicles and all. Might be, I don't know if they have improved into different concept, but you will keep moving the vehicle around, and you will also probably augment it with the satellite, and then you will have to say like what is the road condition, and then this data has to be updated. What are the challenges here? You will have to ensure that you have a very good video capture that actually happens, and this entire video has to be analyzed. So you can't do a real-time update because the data bandwidth that is required from each vehicle is extremely high, and it has to be high definition, not only the forward, but it has to be multi-dimensional. This is going to be the challenge. So if you don't have a good network, or sorry, the map, the network in the sense for the data uploaded, so you will not have the good map, or it takes a long time to update. So like I was telling about, what if there is a change of one way overnight, what will happen, right? So what is being done over here? Okay, why is it not playing? Let me play. So what our system, some of the system will do is
in the coming years,
capturing
mobile
the data,
ISOCs will be in tens of
and entire computation of what the vehicle actually look, because it is already doing the inferencing, right? It is able to identify, I saw a vehicle, I saw a person, I saw a wall, I saw a tree. If that information, whatever that has been inferred, if that entire inference data is collated and it becomes a metadata, and transmitting that only that metadata into a server will enable for a better inferencing about identifying how my local map is, instead of actually pushing the entire video. This is again an add-on to the existing system what actually goes in, right? What is the benefit? I have very less data that captured, and the end device, which is intelligent to identify all my road dynamics, is able to infer and then send it. A lot of computation actually happens here. So it becomes a crowdsource when all the vehicles which has ADAS or these kind of camera devices start pumping the data, you are enabling the wisdom to spread to other vehicles. So if the vehicle comes to some place for the first time, it exactly knows what the environment is all about. Okay, we take it to the next step, which is planning and actioning. So I'll not go in detail. So basically what happens is, this is a real one where we have the GPS versus a local map also when the vehicle goes in the tunnel. And also we have an aggressive mode. I'll quickly go to the aggressive mode to demonstrate how the vehicle actually behaves exactly like a human.
And now this route, even though it's pre-programmed, has the car been told anything about this route? Or is there any special care for this route?
Nothing special about this route in the driving policy. We intentionally make it scalable by not doing any tweaks or tricks solely for this route. So
it's an autonomous vehicle
we
running
accelerated a little bit. You may wonder why.
It's accelerated,
and then we brake. Now we
this guy's not going to let you in.
So what it did, the vehicle started giving a jerk, and it accelerated and then gave a jerk, and it sensed the vehicle that is coming in the back, whether he's going to give a space to me or not. And sensing that he did not give the space, it went on for some time, and next time it tried, and then it went on. This video is available, but point I'm trying to say is these are all actually happening real time. It's a live one, which I've taken as a video, and then you can probably
we
see
know the speed limit based on traffic signs, and also based on our map.
So it has a map, and then finally you are able to do the autonomous driving. So if I summarize, it has a 4-stage: sensing, inferring, planning, and control and action. The challenge that are involved is like, how do I do with each of the stages? The ADAS and autonomous driving, the generally 5 stages. Some people also say 6 stages. The challenges involved in sensing, especially when it comes to image, it has a lot. It has to identify what type of object, and extended data, like I mentioned about the gray spot, accident spots, or the driving profile of a driver, and also the REM, where it is able to manage, and which actually eventually leads to the autonomous and which is real. So this is a quick takeaway. I know I've taken some time. It's already 55. So I'm open for any questions or any comments from anyone.
Participants, the chat is now open. You can type in any questions you have for Sir in the chat box.
Right. Participants, this is your opportunity to ask your questions in the chat box for sure. Also, I would request Shrey to actually put up the subcategories of this particular category of robotics, which we have and which the students would have to be preparing for as they submit projects for ISEF. The speaker has very kindly told us about, by ways of, the project and by the videos that have been shown. But if it is possible, Shrey, can you have the categories put up separately, the subcategories, please, so that students may actually ask the speaker questions on the subcategories as well.
Sir, you're on mute, sir.
Okay, thank you. Hey, Shrey and Sharon, while you are actually getting that, I thought I'll share some things. The reason I exposed all these aspects of what goes behind is these are the different challenges that one you can think of. Because we have seen, especially in the context of, in the multiple um, um, years, there are a lot of efforts from people to see like how do I make my road safe, automatic detection, automatic braking and all. But you will have to be aware saying that it might go through or not, because it is not yet fit for deployment or the challenges that we have. So if at all it has to get matured, I know it is something very hard, but only when you aim for moon, you will actually be stars in the sky. So you'll have to hard hit the real problems. It can be a simple like a um, rumba, which is a vacuum cleaner which cleans the home. Um, it is programmed, it actually does the analysis. It should all lead into those aspects for you, and how you can look out and design some of the machines, and also what it takes for those kind of computation. So it should enable you to think what are the different stages, what your contribution, what are the challenges, what you will invent, what are your USPs, and what you will reuse, what are the systems that are available that you will have to be aware of. Yeah, over to you, Shrey.
Right. So thank you. Thank you so much, Prasanna sir. We've got the subcategories of robotics and intelligent machines on the screen right now. And we also have a number of questions in the chat section, which I think Sasha and Ishita will be calling out right now. The subcategories being biomechanics, cognitive systems, control theory, machine learning, and robokinematics. There are explanations for each of these categories. And having looked at the slides presentation and the videos which were just brought out by the speaker, once you make the connect, if you could ask the speaker about these various subcategories as well, because if you choose to enter your project in the robotics and intelligent machines category, your project could actually be part of one of these subcategories over here.
The first few questions coming in from our participants today are about accessing model data. They ask, from where can we access the model data and how can we access it?
Okay, this is one of the greatest challenge that everyone will have. You will have to identify a domain. Say like there were a few um, interesting the data set that people were working in. It can be to as simple as I want to identify which bird am I seeing because I'm not aware of the bird when I go to the forest. So I click on. It's almost similar to say Google Lens, right? I take a picture and then it actually says like which bird it is. Now for doing that, there has to be a machine which has to have learned already. Where do I get the data set? So you will have to definitely be in touch with any of the institute to which is working on that. In the context of the data set for driving, as I mentioned, IIITH is there. You can always do a Google search, IIITH IDD. You will get an access to the data set. You can make use of it. But if you, generally the data set is always a challenge, but it always depends upon your reach to the universities and to the companies. Like with IIITH and with our company, we have exposed it to the global. Anybody can download and then make use of it. So you will have to reach out to the right institutes and the companies. There's no straightforward, it depends upon what type of problem you're trying to solve, and then you will have to get the corresponding data set. Make sense?
The next question, sir, is from Adit Luthra, who writes, can you tell more about the programming that goes into an AI system?
Okay. So I was discussing with some people on the other day. They were actually trying to compete on some small robotic gaming and all. The programming can actually be part of those kind of a the control system as such. In the sense, I identified that there is an obstacle in the front. Now I want to take a right turn. How much right turn will actually should be taken, and what is the speed of my motor, and in what increment my stepper motor needs to be fed, and what is it the loop, and then how do I take the feedback and then correct it accordingly. So you can do these kind of things using, say, a simple C program. If the systems of, when it comes to the control aspect of the system, it can be done in C using Arduino, any of the systems that are available, right? So it can be as simple. But the moment you go into the complex, the complex system where the system is moving at a very high speed, your an action and the response is something that you will be more be worried about. So again, most of the control systems will be done in C because of the speed that is required, because the smaller the amount of, but on the programming side of inferencing, identifying, so building the data model, you can go for some Python programming because it has a lot of the backend infrastructure and all that can be made available. You can have your own instance of the compute power using any of the processors or the GPUs which are available doing it. So the Python is another one. If you don't want to really go into the challenges of aspect, because you have a lot of background infrastructure that is available from Google or Amazon, Azure from Microsoft, where the TensorFlow from Google, right? So you have the backend infrastructure, so you can ensure that you can collect the data, you can make use of the backend infrastructure to do all the computation, take the inference data, and then control your robotics. It can be proof of concept for now where the things are all working, but the more and more you try to do this, you will have to own some of the components within your system because it has to be done locally. The network may not be reliable. So long story short, Python, C programming are some of the things that we can think of. You can also be looking at the TensorFlow access and then the Python, the Azure and all for any of the backend infrastructure that you're going to rely on for showing some of the proof of concepts. Hope it's clear.
The next question, sir, comes in from Sandhya, who writes, sir, can you please tell us some areas in robotics to introduce amongst students at school level?
Okay. It all starts with creative things in the mind, right? though I don't really see, I mean, I don't want people to take it in a negative way. Microsoft um, founder Bill Gates actually told very once, the people who are lazy are the best innovators, right? So simple example, like I'm watching a TV and I told, okay, it's a random, and my remote is very far off, or my mobile phone is very far off, and I get a call, and the mobile phone has to come to me, probably using a drone, okay? And how will it come to know? It can be either through image processing or maybe through some 3D sound, okay? I make a sound saying that with a visual, and it has two sensors, and like Amazon Echo or Alexa, they all have the directional, because it has multiple microphones, so it can come to know from where it is coming. So from that way, it can even come to the right location. So this might be a crazy idea. Who people will think that who will need this, but believe me, this is how the whole thing starts. So for any of you, first you need to start thinking about a crazy thing. When I was doing my engineering, maybe 2 decades before, we actually wanted to design a scooter with an automatic braking, and how it can actually happen, because most of the problem that actually happens is because the braking is not done at the right time, and the impact will be much more. So we came out with, and I started seeing so many things that are coming out as a prototype and all, because I was a driver, I was driving my bike, going to ISRO for my project and all. But then the ideas came in. How can I make my vehicle? So you will have to be crazily, involved in everything that you do, in say probably to the day-to-day activities, and then identify what is a problem that you want to really resolve. There cannot be anything which actually says this is a right prescription or anything, but you will have to be innovative to create one. Maybe this lockdown has helped a lot, okay, to come out with what you wish to be, probably physically seeing each other and all with your friends and relatives and all. You can think a lot about it. Haptic feedback for sensing, okay, the remote operations that what people are talking about. So many things can actually come out, but if you say that are these things not there, of course it is there, but your contribution on how it is done in a different way and an affordable way, what matters. So I don't know if I answered you, but you will have to be crazy enough to identify what all the problems that you need to really solve, right? The problems are there out plenty. I know I made it generic, but but you will have to find out. I cannot prescribe anything. Okay.
The next participant who has a question, sir, is someone who has their hand raised. So, Tanvir Singh, I will now unmute you and you can ask sir your question.
Still, he is on mute, Tanvir. Yeah. Still on mute.
Excuse me, sir.
Hey, Tanvir, I think I can hear you, but you're going on mute.
Excuse me, sir.
I can hear you.
Sir, can you again explain about machine learning?
Probably I'll have to start sharing the slides and all. Okay. Let me quickly share what it's all about. So I'll give an inference. Probably you can really make use of, learn from with that inference. What is machine learning? Okay. You will have to expose your system, diversify data, more and more data, and you will have to teach what each of these things are. Like I said, there is a child which actually saw a dog first time, and you taught it saying that, hey, it is a dog. Next time it saw a cat, then you say, hey, no, that, and the child said it is a dog. Then he said, no, all four-legged animals with a tail is not dog. It is a cat. Can you see the difference between a cat and a dog? And you start explaining the features. So you will start extracting these features and then start segregating. And that becomes the system, an algorithm, or the way it gets exposed, which enables to identify the data separated out. Now, this can actually happen through two ways, right? I mean, one is through the supervised way and the other one is an unsupervised way. Supervised way is like the child being told by its parents or the guardians or well-wisher, saying that how to distinguish, maybe the teacher, distinguish between a cat and a dog. Over a period, the child actually identifies to distinguish between those features. Hey, it looks like a dog, but it is not dog. What it is, if that is a question that it asks, that means it has already done an unsupervised learning of distinguishing some of the features of each of the type of a dog. Maybe it is actually identifying between a dachshund and a greyhound or a dachshund. So many things that it is able to identify. What is the difference between that? It is able to categorize. So that is actually the unsupervised learning. So all these things can be part of the machine learning, and you can actually make use of the different techniques, the clustering and so on, to identify what all the different ways of the unsupervised learning and the supervised learning. Okay, this is on a nutshell. You can probably engage into some of the basic course in say Udemy or any other thing, and then probably go deep into it. Hope that explains Tanvir Singh.
So the next
Tanvir, just want to ask Tanvir, which class are you in? Tanvir, question to you, which class are you in?
Ma'am, I am in 7th class.
Okay, when you reach class 8 and if you're with CBSE, then you will definitely get an answer to this question if you take up artificial intelligence as a subject with CBSE.
Okay, ma'am.
Hey, I like your inquisitiveness. Cool. Keep going. Keep learning.
So, ma'am, there's a question on personal chat from Chirag Varna, who says, "Sir, I have already started making and have an ongoing research project on a robot in the kinematics category, as he's developing a humanoid that will be programmed to be in response for dangerous situations, which I'm assuming is a disaster response robot. So he has already started his work on it. And his question is that will he be accepted for making junior research for exhibiting it in the IRIS National Fair?"
Okay, so I would always explain these things, right? So ideas are always welcome. So what your system can always do, it's something similar to say like what can be patented, right? So it is something like that. So anything which is differently done to solve probably the same problem or a new problem is always good. So from the generic aspects of saying that an assistance to identity combat to the dangerous situation, perfectly fine. But how are you going to do? What amount of adaptation the system is going to be, that evaluates for you to say whether it will get qualified only when we see that it happens, right? It should not be something like, okay, if someone has created or something, you will have to identify what is a unique problem you are trying to solve and how it is solved. Okay, like I always keep distinguish to what can be patented and what cannot be patented. I always give this example. Someone said like, okay, can we come out, I am having an idea where I dump some of the learning that I have. If you can all recollect the Matrix movie, I want to drive an helicopter, so download the helicopter software into my head, and suddenly I start driving the helicopter. Can that be done? Superb idea. Can that be patented? Absolutely not, because ideas cannot be patented. Ideas will always be great, but how you do to dump the helicopter driving mechanism in such a way that it gets into the human memory and it becomes as a part of it as though he has learned, is something that you will have to explain and you will have to show, right? That method is something that can be patented, but not the idea. So in the similar context, your idea is great, but it depends how you have done, what is the problem that has been resolved. Hope that explains. Okay, any other questions?
So I think the team is sifting through the questions because there seem to be questions which are repeated. So, they don't want to trouble you by asking you the same questions over and over again. But participants, please pay attention to the answers which are being given. We will ask your questions provided it has not been asked before.
There's a question coming in from Amiteshwar, who writes, "Sir, could you please give some inputs on machine learning in the area of medical imaging?"
Okay, so this is one of the interesting area. There's a lot of things that are happening, especially on the medicals. And in fact, we have seen multiple proposals coming in the years in this current domain, right? So yes. So what it takes for medical, okay? So it can be for identifying some of the scanning, analyzing the scanning reports, identifying the patterns which human eye cannot, or a solution where there is an expert, he's in best of the hospital, and he want to scale the identification of the problem in the multiple locations. That scaling can actually happen. So what it means is, if the person is able to distinguish between a cancerous image versus a non-cancerous image, and he is able to distinguish, then probably he is actually enabling the system through a supervised learning. Now, once that supervised learning can actually happen, now you can do remotely, take the similar kind of images from different places and feed it to the system, and it will mimic like what the person has done, had it been the real person. Or there is another way where you can augment the supervised learning and also enable the supervised learning to say, like, by unsupervised pattern identification, and help the expert himself to see, like, can this also be a cancerous tissue or a cancerous growth, which probably he would not have identified from earlier scannings. So these are the different things that are actually enabling, where you are augmenting the existing identification with more. Furthermore, or you're creating an infrastructure where the telemedicines or remote, especially in the villages and all, you can enable to replicate the experts in multiple locations. If you can come out with, say, mobile-based application where you take the picture of an eye and then you can say what is the power, probably that is something that you can think of. Or if there is a problem in the eye, that is something that you can think of. There were few systems that were actually provided where, in fact, Dr. Devi Shetty from Narayana Vidyalaya had told, my friend had come out with a low-cost ECG machine which can be deployed to the people and for heart monitoring from a remote. So he said the accuracy is around 70%. That what it means, of the 100 people whom we actually send to doctors saying that there is a possibility of a discrepancy in the ECG, 30 people may turn out to be it is incorrect. And Dr. Devi Shetty said that is also okay, because I don't want to lose the 70% of the other people whom probably it would have actually be the case. So they are perfectly okay even with a low accuracy, provided if it is actually of a lower cost. Of course, your system can evolve to be more and more accurate based on the different data sets. So there are a lot of imaging based, the breast cancer detection, so many things that are actually coming as a part of the innovation. So long story short, these are all the different imaging techniques that can be used by using the neural networks. The only thing is you'll have to have certain domain knowledge to identify what all the patterns, what you need to detect, and how you make use of the system to evolve to the next level.
Thank you so much, Prasanna sir. We now have an AV, because we have a lot of people who have registered for the first time. We would like to play that AV. This will give an oversight on how one needs to register for IRIS. So we have the AV now, and then we can come back to the chat section.
Are you ready for the ride of your life? Well, it all begins right here. Your first step is picking a category you can enter by yourself or with a partner. If you're in 5th to 8th standard, you will be in junior category. If you're in 9th to 12th, you are in senior category and have a chance of making it all the way to ISEF. Now that you know which category you are in, it is time to find out which subject your project comes under.
At IRIS, you have a variety of 21 subject categories to choose from, ensuring that your project has a category that fits. The categories include animal sciences, behavioral and social sciences, biochemistry, biomedical and health sciences, biomedical engineering, cellular and molecular biology, chemistry, computational biology and bioinformatics, earth and environmental sciences, embedded systems, energy, sustainable materials and design, engineering mechanics, environmental engineering, material sciences, mathematics, microbiology, physics and astronomy, plant sciences, robotics and intelligent machines, system software, and transitional medical sciences.
A display shows the public and the judges what you have done. You're looking to attract and inform visitors about your project. To make it easy for people to access your results by creating a clear, attractive and concise display. The focus should be the work. Take a look at this reference. Your title should be simple and must accurately represent your research. Take photographs or videos of important parts or phases of your experiment to use in your display. Prepare a miniature of your model in case your prototype is too large to be carried along. Make sure your display is logically presented and easy to read. Use neat, colorful headings, charts, and graphs to present your project. Pay special attention to labeling. Be sure to adhere to the size limitations and safety rules when preparing your display.
The IRIS journey begins with registration on the website www.irisnationalfair.org with submission of online synopsis and supporting documents. These entries are prejudged by the IRIS Scientific Review Committee, and shortlisted projects are sent an email inviting them to participate in the IRIS National Science Fair. Winners of the IRIS National Science Fair qualify for an intensive series of mentoring camps and get the opportunity to represent India at platforms such as the Regeneron International Science and Engineering Fair in the United States of America. ISEF is the world's largest pre-college STEM competition. Over 265 Indian students have won over 160 awards at this competition, competing with over 6 million high school students from all over the world each year. Not only are you getting a chance to make your nation proud, but if you're lucky, you could join the 31 Indian students who have had minor planets named after them.
So guys, please don't miss this opportunity.
It's your turn now.
If you're innovative and you really want to bring about a change in the world, I think IRIS is the right place for you.
If you enjoy science and math and computer science and so on, so I mean, it gives you a platform to show what you've done, and you have a chance to go to ISEF too.
If science actually kindles your curiosity and you're really passionate about it, IRIS provides you the largest platform in India to show your talent.
Applying to IRIS, not only get to have a great experience, you meet great people and great mentors at that. They're not judges, they're not judging you, they're mentoring you, they're teaching you. They make you learn new things.
In the end, it's not about winning or losing, it's about experience, and IRIS National Fair guarantees great experience. Don't tell people what your dreams are, show what your dreams are through IRIS.
It's once in a lifetime experience.
It's your turn.
It's your turn. It's your turn.
It's your turn.
It's your turn.
It's your turn.
It's your turn.
Right. Thank you so much for the AV. And participants, we hope to see many of you registering for IRIS as soon as registrations open. Please feel free also to visit the IRIS social media pages and the IRIS National Fair website. Team, is there anything more in the chat that you would like to call out? I think there is one question about what is the fee? There is no fee, so to speak. So,
Sharon ma'am, there's a question from Adit Luthra.
yeah.
Has asked that he's been applying for IRIS for the last 2 years and has never been selected. So he would request for some advice on what would make a project be selected.
So a project is normally selected to IRIS based on uh, it having an original innovation and it being something that will benefit the community. So you have to be very, very conscious about whether or not this project, this idea has been done somewhere in the world. If it has, then it will not qualify as an original innovation. However, having said that, if you are building on something which has been done in the past, you should be able to justify how what you are doing with that innovation is something new and something which has not been done before. Our scientific review committee takes great pains to go through each project and to check whether this is something which is original and unique, or whether it is something which has been lifted from somewhere. The scientific review committee is very strict about ideas being one's own and not something that has been taken from somewhere. And so each of the projects that are submitted or that are received as submissions as synopsis for the IRIS National Fair go through a very, very thorough screening by experts in various subject categories. I hope that answers the question. So we always say you are welcome to try again, and we hope that you get selected this time. You know, there are other questions that I see in the chat which are very specific about potholes, etc. At the, I mean, see, the thing is, if you have a project idea, you need to research that and write a synopsis and put that across. Try not to share project ideas in the chat section,
Exactly.
which can be taken by other people, because your project, your idea is unique to you. Prasanna, would you like to add something to that?
Yeah, exactly. But one thing I want to share is like exactly the pothole detection is one of the greatest innovation that can happen. And how do you find it? How do you accurately make it? Is it something that you can provide an infrastructure to contribute for ecosystem, saying that if you are driving, someone has gone through a pothole and then he detects and then notifies you saying that, hey, there is a pothole there, something like that, right? So if that actually happens, make it real. It's wonderful. Now, it all starts with an idea like what Sharon already mentioned. So keep your ideas to yourself and you will have to evolve saying that, okay, I have a problem. Now, how do I solve it? And what are all the challenges? That's how the things will happen. Many times, like what again Sharon said, like if you would have proposed an idea and someone rejects saying that, okay, this is already there, it might be that you would have thought individually on your own for the first time. You are your creator on your own because you have not read anywhere. Perfectly fine. But please remember there can be multiple people be thinking on the similar lines, and that's where the things will be hard to absorb, right? So keep it with yourself, take on, find a way how it can be solved. So I wanted to, I was just looking at the question there in the related to the pothole. That's what I wanted to say. And aviation sector, I'm not very familiar, but again, if you're looking at the drones and autonomous drones and all, it is a complication plus plus, right? Because whenever you are driving on the road, it's virtually two-dimensional because you are on the road. But if you are driving, if you are actually having a aviation, like in the context of drone, it's a three-dimensional. So you will not only have the obstacles in the two-dimension, you will have the obstacles from the three-dimension. In fact, our company and many other people are also having a lot of drone solutions for the navigation. Yeah, it's a good challenge, but you should ensure that you are creating on your something different. So detect fire on the road and the potholes. Detect fire. Yeah, I mean, as long as your machine learning is able to identify different topics, if you can make one, and if it is something like, are you going to solve a frequently seen problems, or you're going to solve a rare problem? It's up to you, correct? So it's all about the management, saying that how much you are investing to solve a problem where its probability is very, very low. However, if the impact is very huge, then it is a different thing, right? You can use it. I mean, though we are talking about the autonomous vehicle here, you can also extend the logic for security cameras and all. There are a lot of ideas that can actually build on, especially when you talk about the fire and all. Potholes, we already talked. And
right, there's a message coming in from Zen. Thank you for that message, Zen. We do remember you as a participant of IRIS. And yes, unfortunate circumstances that we not go ahead with you at IRIS. But yes, thank you for that lovely message. And thank you for putting it across that even though there are disappointments, successes follow for sure. And
okay, there is one question, I'll answer that and probably I'll stop. Huh?
Yes, Prasanna.
Yeah. So there was a question saying that how do vehicle detect the different speeds? Okay. Very good question. So as a part of the sensor, the radars are used for identifying the speed of the vehicle. You can also do through the imaging based on the perspective view of the image processing. That is one input. And then finally, the sensors directly from the CAN bus, where the CAN also gives the data saying that what is the speed of the vehicle, and because it has to display it on the odometer and all. So the information is also shared on the CAN. So I get the speed of my vehicle, I get the perspective view of the other vehicle, and I can always do with the knowledge of the geometry or the physics, I can always see what is the and also the input from the radar using the Doppler effect. I also can identify what is actually happening with respect to the reflection that is coming, and I can always identify the speed of the vehicle which is going in forward. What I mean is to make the all these things. If a perspective views the size of the image which is there in the forward is at the constant size, and your vehicle is moving at a particular speed, you can always see that okay, that vehicle is also moving at the same speed as your vehicle. And rest all the things you can always identify. If the size of the image actually increases, that means you're going faster and that is slowing down. On the vice versa, if it is becoming more and more smaller, it is going at a higher speed than what you. These are some of the inferences, the logic that you can always build. Okay, with this I'll stop.
Yeah, thank you so much, Prasanna. Thank you for giving us so much of time. It's really unfortunate that when we began, there were about 85 people and now we can see just 41. I think people have kind of dropped off during the webinar. Very unfortunate, because I think there was so much of information over here that would have helped participants who wanted to pursue a project in this category. However, the recordings...
I saw people probably from the question Q&A, they started dropping. So
yeah, so yeah, the recording,
they would
of
have
course,
felt two things. One is they understood everything, they are very happy, or they say that okay, this is not my field, let me get out. Okay, jokes apart.
So yeah, so the recording will be available on the IRIS National Fair website for anyone who wishes to refer to it. Thank you so much, everyone. Thank you for joining us this evening, and a very special thank you to Prasanna for taking time out to join us. We are so happy that this platform brings in people from diverse backgrounds and diverse fields, diverse yeah, there are people who have come in from various corporates. There are people who have come in from government organizations. There are people who have come in while they're just starting out on their career. There are people who are stalwarts in their career who have come in and helped. And I think it's all to help students actually pursue their projects in the domain of STEM. So thank you so much, Prasanna. Thanks once again. And thank you, IRIS team, for all the support during the webinar. Thank you
Thank you
so
very
much,
much.
participants. Have a great evening.
All the
Bye-bye.
best to everyone. Bye. Take care.